26. I'm Paula Jasper. Today we're in Gaylord. We're at the Gaylord Weather Service, and joining me is meteorologist Jim Kaiser. Thanks for joining me, Jim.
My pleasure.
Now, we have been hearing a lot of talk about possibly a warmer, drier winter. Can you please explain why you think that may happen?
Well, we have to go back to understand sort of the factors that play into how the winter sort of takes shape. And a big one this year is something called El Nino. And people have probably heard that before, and that is a warming of the water in the Pacific Ocean. And you may say, why does that matter for northern Michigan? But it affects the track of the storm systems and sort of where the warm and cold air sort of places itself across the United States, and it's dictated by those temperatures in the Pacific Ocean. So this is a strong El Nino year. And when we go back and look at other strong El Nino years, the last one we had was 2009, 2010, but there's a number of others all the way back into the 1950s. We can look at 57, 58, and 1972, 73, and 97, 98. And when we go back and look at those years, what we find is that there is a strong trend toward drier conditions, below normal snowfall, and warmer conditions above normal temperatures. And so that's the direction we think the winter's headed.
Now, you were sharing with me earlier that people still need to keep it in perspective.
Well, they do, because this is still northern Michigan. And although when we say things like it's going to be warmer and drier, that could still be 80 or 100 inches of snow for some locations, which for most of the country would be considered a severe winter. So not anywhere near as cold or probably as snowy as we've seen in some of the last couple of winters. But, let's not completely let our guard down. There still will be snowstorms. There's still going to be difficult driving at times, and all those things are still going to happen. We just think a lot more variability this year, probably a lot more melting in between snow events this year.
Oh, interesting.
Yeah.
Okay, can you give our viewers a little idea of what's in your backyard here at the Weather Service?
Well, there's a lot of things in the backyard here. We're standing in front of some of the satellite dishes, and a lot of the information we receive and send out is done via satellite now, which is a much more efficient way to get the information in and out. Other than when snow covers a dish, and we have to, just like everyone else, we have to brush it off. We can also see in the background here, the building back here with the white top on it. That is the upper air inflation shelter, and that is where we launch weather balloons twice a day. And we're doing it right now at 7 and 7, and with falling back in the clocks, that goes to 6 and 6, basically. And so that's where we get weather information, not really what's going on at the ground, but thousands of feet up in the atmosphere, which is really the important part of weather, is really what's going on up there, not so much what's going on right here.
Makes sense.
And the feature over here, if you can sort of see it in the distance here, that's sort of got, it looks like some wooden fencing, and there's some instruments over there. That's actually a climate site, and there's only about 75 of those in the entire United States, only 2 in the state of Michigan. And they were put in to monitor long-term climate changes that are occurring. And so they found locations that they thought were going to be undeveloped sort of over the next many decades. And they want to get a good picture of what's happening with, how we see differences in solar radiation to temperature to dew points and wind direction and wind speeds. And they get a good idea of that, tracking that minute by minute, basically, all throughout the year.
Interesting.
So, and then the one big feature,
it's like
it's the elephant in the room, yes. The one big feature right here, of course, would be the Doppler radar, or the big soccer ball, as many people refer to it as. This is close to 150 feet tall, and is built to withstand winds of 150 miles per hour. So, which is important when you're talking about hurricanes and tornadoes and things like that. Inside of that is really what would just a large satellite dish. And that's what's really turning all the time and sampling the atmosphere, looking for an object to hit. And when I say an object to hit, you say, well, what would it hit in the atmosphere? And I would say, well, a raindrop or a snowflake or a piece of ice. And when it does hit something like that in the atmosphere, some of that bounces off the object, comes back to the radar, and then sort of gets processed, and eventually we see it in our office, and everyone sees it at home, when they're watching TV or when they go to the internet and they're seeing that pretty radar picture.
Right.
This is where it starts, right here.
Okay, Very interesting. Thanks a lot, Jim.
You're very welcome.
Paula Jasper, -26 in Gaylord.